Hello. This video is actually an extension of a couple of videos that I have done earlier, and in this video I am going to connect some of the concepts that we have talked about previously in the context of a simple example. I have selected a two-dimensional problem, maximization problem, maximize x1 plus 2x2 subject to 4 constraints. Two of them are less than or equal type constraints. Two of them are greater than or equal type constraints. I have selected the x1 and x2 to be greater than or equal to 0 so that the feasible region will be in the first quadrant. If we plot the feasible region, the polygon JFEN is our feasible region. And just in case, if we plot the z function lines, we will see that point F is actually the optimal solution of this problem. Convert the problem into the standard form. For the less than or equal sign, we are adding the slack variables, and for the greater than or equal sign type constraints, we are subtracting the. So our problem will have 6 variables. This is a problem that has 6 variables and 4 equations. Thus we will have 2 non-basic variables and 4 basic variables. Let's pick up an extreme point. Whether it is feasible or infeasible, it doesn't make any difference for this process. But let's pick up in this case the point F, the optimal solution of the problem. Point F is the intersection of line 3 and line 1. It is the intersection of these two, so the slack variables for these are going to be 0. Therefore, immediately I know that S1 and S3 are going to be my non-basic variables, and X1 and X2 and S2 and S4 must be calculated, and those are the basic variables that I will have for this problem. Incidentally, if we solve the problem using Lindo, for example, this is the final result that we would receive for the problem. It really doesn't make any difference in the location of these variables. Ahead of time, I don't know how the basis is organized through simplex method. However, I can write this problem and find the solution using another technique. And for that, because I am just looking at x1, x2, s2 and s4, I can rearrange this tableau to form it to be like that, and for that I will just move this row above the x2 row. So I will have this tableau as final optimal tableau. I will come back to this later on. So at this point we are going to take a look at something that we did in previous videos. In this case, I will write the matrices that are involved. Matrix A, column vector B, row vector C, and the S variable entries. Now notice that in this case, now S2 is now -1 and S4 is -1. That came from the original problem. When you look at these cases, that is -S4 and that is -S2, and we are going to put it in the problem the same way that it is formed. Now we are going to create our xb, and as we talked about it, x1, x2, s2, and s4 are our basic variables. I will form the matrix B. If you remember, I will form the matrix B from this. Each one of these are related to the variables in here. This column is associated with x1. This column is column of P1 associated with x1. X1 column is right here in A, and I will write those numbers. X2 column is the P2, and that is right here, and we're going to write them in here. S2 column comes from this one, and that is a negative 1. Don't forget, there is a negative 1. So that column is right here. And S4, which is this column, same as S4. I would write the CB, the coefficient of the objective function of this basis. X1 is 1, X2 is 2, C1, C2, and for S2, which doesn't exist in the objective function, it is 0. For S4, the same way. Now the tableau structure has this form, and we have talked about it before, so I'm not going to spend any more time on this one. This is the tableau structure, and this model is formed based on that tableau structure. Notice that this tableau is exactly the same tableau that I have in here as the tableau for that specific extreme point. And again, it doesn't make any difference which extreme point you are selecting. It is exactly the same thing. So let's go back and review. You pick up any point. For example, if I pick up point E, extreme point E, which is a feasible extreme point of the problem, then point E is the intersection of L2 and L3. Therefore, S2 and S3 are 0, they are non-basic. S2 and S3 are 0, they are non-basic. And then the rest of the variables are basic. Exactly, you can repeat the same process and get a tableau for that one. Now, because both F and E are basic feasible solutions, in this case, your right hand side will be positive or greater than or equal to 0. It will not be negative. There shouldn't be any infeasibility in here. For point F, which is the optimal solution, we will not get any negative values in the 0 because the answer is optimal. But if we process point E in this tableau, we will get some negative numbers because it is not an optimal solution, and you can still improve the solution based on that. Now let's say that you select another point, point D. Let's pick up point D, which is the intersection of L3 and L6. Point D, of course, is a infeasible extreme point of this problem. For point D is the intersection is on the intersection of L3, so S3 will be 0. Also, x2 value for point D is 0. So our non-basic variables for point D are x2 and s3, and the rest of them are going to be basic variable. And as such, when you set up this tableau, you will be expecting to get some negative numbers in here, which shows the feasibility. Remember that the right XB needs to be filled out, the right B needs to be filled out, the right CB needs to be filled out. However, when you calculate this new tableau with the new basis, using the new values for B and CB, you will expect to get some negative numbers in here, 1 or maybe 2, we don't know ahead of time, but we will be getting some. Can we say how many? If you look carefully, yes, you can. Point D is feasible for everything except for line L2. It is feasible for any other constraint that we have except for L2. Therefore, your S2 value is going to end up to be negative. So you can say that. For example, if we did that for, let's say, point H. H is the intersection of these two lines. H is the intersection of L4 and L3. So S4 and S3 are non-basic and the rest of them are basic. However, point H is infeasible for L1, so your S1 will be negative, and it is also infeasible for this line. That's the line which has the x1 greater than or equal to 0. So your x1 will end up to be negative. Of course, we can see that in here as well. If you go for point A, you would get S2 negative, you would get x1 negative, and you will get S4 negative, because this point is infeasible for those lines. Well, I hope this helps with your work.